Rise up or run down. We mapping graphs to the triple R sound. We talking points and slow actions and origins. Why intercept and pause and solve for them. Rise up, run down. We mapping graphs to the triple R sound. We talking points and slow actions and origins. Why intercept and pause and solve for them. The four quadrants start from the top and right. Counterclockwise from the positive X and Y. You go around, hit the 2 and then 3. Bottom left, negative. Remember that, please. You got a single point on the X Y grid. There's a single pair of values telling you where it is. This X coordinate goes from side to side. The Y follows the compass to define the point I. A straight line between 2 points is a relation. You can represent it with a linear equation. Y equals M times X plus B. If you want to know the variables, listen to me. M is the slope, that's rather a run. It tells you how steep the line is going to become. B is the intercept, that's how you assess the point at which the line goes through the y-axis. Rise up or run down.
The title of my project is Supporting Students' Understanding of Linear Function, a review of the literature. The purpose of this literature review is to review historical and contemporary literature on the use of the graphing calculator, specifically the TI-83, TI-84, Casio FX 1.0, Casio FX 2.0 Plus series on students' learning of the linear function depicted by graphic, tabular, and algebraic representations. Another goal is to discuss major themes that emerge from the literature. The National Council of Teachers of Mathematics called for curricular reform and suggested there be a greater emphasis on the function concept for grades pre-kindergarten through 12 in 1989 and 2000. The concept of function is foundational and central to secondary and undergraduate mathematics. It is not only integral to the understanding of more rigorous facets of the discipline, but it is pivotal in understanding the connectedness of symbolic and graphical representations. Lienhardt, Slavosky, and Stein said, "Functions and graphs represent one of the earliest points in mathematics at which a student uses one symbolic system to expand and understand another." Situated in sociocultural theories of learning emphasize the effects of context, environment, and socialization on the development of schema, outcomes, and products of learning. Mathematical tools serve as mediators of students' learning. There exists an iterative and mutually reinforcing relationship between the tool, the user's actions with the tool, and the cognitive processes and structures established by acting on the tool and vice versa. The graphing calculator, like many other technology tools, affects students' opportunities to learn mathematics. Because the tool is readily available in most middle and secondary mathematics classroom, it is important to explore how students use this tool to conceptualize meaning for linear functions. Major themes that emerge from the literature suggest that the use of the graphing calculator supports students' trivialization, provides access and support for inquiry, and reduces the cognitive burden of many tasks. The graphing calculator trivialized the production of graphs by requiring little intricate knowledge on behalf of the user. Users only need to know keystrokes. For example, students are able to graph the function y equals x plus 3 by pressing the following sequence of buttons. Similarly, students are able to construct scatter plots using the graphing calculator with relative ease by pressing the stat and edit buttons on the calculator followed by other sequences. Because the graphing calculator trivializes and amplifies learning, students are able to engage in the investigative process of observation, conjecture, proof, implementation, and application within the context of real-world problem scenarios using the graphing calculator. The graphing calculator is also less expensive than other one-to-one devices and performs algorithmic and algebraic processes automatically. This lessens the cognitive demand on the user and provides access to users who might be struggling with requisite knowledge. The graphing calculator helps students to conceptualize linear function by allowing them to transform representations, to model with mathematics, and to visualize. The tool allows students to visualize multiple representations of linear function as follows. By selecting Mode and changing to GT, students will now be able to view a graph and table simultaneously. Again, students will be able to see multiple representations of the same linear function depicted. We can graph y equals x and construct the line as well as the scatter plot and the table. Another key feature, as discussed in the literature, that supported students' conceptualization of linear function, their ability to transform among representations, and their ability to visualize regarding linear functions was the use of the zoom feature. Here I will demonstrate how the literature discussed students used the zoom feature of the tool. We are going to graph y equals x minus 3. And now I will demonstrate how the students use the zoom feature. Students use the zoom feature. They zoomed in to identify the solutions or the x-intercepts of the linear function. Again, key uses of the graphing calculator were the zoom feature to identify intercepts, and the use of the table, symbolic, and graphic forms to reason among and between representations of linear function. Still, the literature discussed several constraints of the uses of the graphing calculator to support students' understanding of linear function. The graphing calculator has limited dynamic motion, meaning that students are not able to grab the graph and move it like they are with other dynamic software. Also, students' use of the calculator might be done rotely. Students do not have to have requisite knowledge in order to use the keystrokes for the calculator, which means that they might arbitrarily input something into the calculator without understanding the underlying mathematics. Additionally, there is a lack of color on the graphing calculator, specifically the TI-83 and TI-84 series. The Casio FX series does have color. A last restriction of the graphing calculator is its restriction on symbols. Students are only able to input using y and x for the variables. This might constrain their understanding of parameters and the uses of variables as it relates to linear functions and contextual problems. This concludes my presentation. Thank you for your time.